All right, derivatives review number 1. If you read the directions at the top, you can see that a, b, and k are constants. So every time we take the derivative, we're going to treat them just like they were a number. Okay, so for number 1, we want to find f prime of x. You can treat this a couple of ways. I personally would rewrite this in the beginning so that it's 5 times b squared minus x squared to the negative 2, bringing it up to the top. There's really no reason to do the quotient rule here because the numerator is 5 and you're just going to end up with a 0 term in your quotient rule. So we have our constant multiple, 5, that's still going to be there. The power chain rule says we can write down our negative 2 powers. B squared minus x squared will stay the same. The power will be 1 less, so negative 2 minus 1 is negative 3. But we have to multiply our answer by the derivative of the inside. The derivative of b squared, since we're treating it like a constant, is and the derivative of negative x squared is negative 2x. Alright, put it all together. The negative 2x, the negative 2, and the 5 are all in the numerator. None of them have a negative exponent. So we're looking at 20x over this entire term with its negative exponent will move to the denominator, b squared minus x squared cubed. Alright, number 2. We have y equals x e to the tan of x. You might look at this and at first think maybe you need logarithmic differentiation. But if you'll notice, x does not have the variable exponent, so no logarithms required. It is, however, a product, u times v. So the product rule is going to apply. So y prime is u times the derivative e to the tan of x. The derivative of e to the u is e to the u times the derivative of u, and the derivative of the tangent of x is secant plus v to the tan of x times the derivative of u, which is just 1. The only thing that I would do here to kind of clean it up is to take the e to the tan of x out of both of these terms. And at the same time, they both have an x as well. So this looks like... Oh, I'm sorry. No, this term on the end does not have an x. So this looks like e to the tan of x times this term has an x and a secant squared of x. This term is just left with this 1. And we've got y prime. Alright, number 3. Here's our favorite thing, those arctangents. So the rule for arctangent was d dx of the arctan of u is u prime over 1 plus u squared. So that's the rule we're going to use here. So g prime of x will look like u prime. This is that u we're referring to. So 6x over 1 plus u, the whole thing, squared. If this was a multiple choice answer, I would almost be sure that this is not going to be left in this manner. So you're going to have 6x over 1 plus, and this would be squared out. That would be 9x to the 4th plus 6x squared plus 1. So you would probably see it like 6x over 2 plus 9x to the 4th plus 6x squared. Alright, number 4. A to the t cubed minus t. This is just like our a to the u formula. So we have d dx of a to the u is a to the u times natural log of a times u prime. That's the formula we're going to use. P prime of t will equal a to the u, so a to the t cubed minus t, times the natural log of a, times u prime, which is that derivative of that exponent, so that's going to be 3t squared minus 1. And if you notice at the beginning, it does not tell us that t is a constant, so that's why we actually had to go through this whole process. So cleaning it up, maybe 3t squared minus 1 times a to the t cubed minus t times the natural log of a. Alright, finally, number 5. We've got y equals the sine of 5 minus x over x squared. We're going to be using our quotient rule here. So y prime is equal to the low, x squared, times the derivative of the high, which is cosine of keep 5 minus x the same, times the derivative of the inside, which is a negative 1, minus high, times the derivative of the low function, which is x squared, so 2x, over the low function squared. If we kind of clean this up a little bit, you will notice every term has one x in it. We've got x squared, we've got a 2x, and we've got x to the fourth, every term. So we can actually cancel one of those out from every single one. That's going to go away, this is going to go away, and this is going to become power 1 less, which will be x cubed. So I would leave this like negative cosine of 5 minus x minus the sine of 5 minus x. We have that, we have that x up front left over, and the bottom is now going to have the power x cubed. And I'm sorry, the term on the end actually had a 2 left over, so we've got 2 sine of 5 minus x over x cubed.